Hi, thanks everybody for sticking around for the last talk at the conference. One of the two scaling talks, so I guess scaling's kind of popular for the last talk at the conference. Anyway, my name's Kevin Lamping. I work at USAA. USAA is a Fortune 500 financial services company. We serve the military, the veterans, and their families, provide a wide range of services, banking, auto insurance, that sort of thing. Any USAA members here today with us? Great. It's great to be able to present to you and have you here. So what I'm going to do today is tell you a story about how USAA built a component-based web framework and scaled that framework up through a series of evolutions. So to begin this story, I'm going to jump back to the year 1922. In 1922, it's an important year for USAA. 25 Army officers got together in San Antonio, Texas, in the heart of Texas, and they wanted to create a new company where they decided to pool their money and insure each other's auto vehicles. And the reason they did this was it's part of the military lifestyle. It's unique. You know, you end up moving around a lot, and you've just have a different situation that you don't have a lot of control over where you live. And so, you know, my wife, her dad, or when you ask her where she grew up, she says, my dad was in the Air Force. So that's where she grew up, was in the Air Force, moving from military base to military base. So they wanted to create a new company that was built around the military lifestyle. And so they founded USAA. And at USAA, we're a unique company. Serving the military and serving the military lifestyle and working around that lifestyle is at the heart of what we do. And so let's fast forward back to this century. You're in the military, you're going to be deployed. And so whether it's overseas, whether it's on the seas on a battleship or an aircraft carrier, or in the seas on a submarine, you're away from your home a lot. And so if we're going to meet our objective of serving the military, we've got to serve the unique needs of the military lifestyle. And so part of being deployed means not having a lot of time on your own to surf the web. And so not having a lot of time, you don't want to spend your free time worrying about paying your auto insurance bill. You don't want to spend your free time worrying about transferring money from one location to another. And so for our members, it's important that when they go to our website is up and running 100% of the time. If they can't get to our website on one day, they might not get to that website, get another chance to go to our website for a week or two. It's just part of that lifestyle. So we need to make sure that our applications are available and that they perform well. The other part about the military lifestyle is they're not going to have liquid-cooled, awesome gaming rigs over in Afghanistan. They're not going to have that. They're going to have what the Army gives them, what the Air Force gives them, whatever is provided to them. It's not going to be top of the line. We definitely still have a number of browsers, IE5, using IE5 as their main browser. So we have to support, not only make sure that our systems are 100% available, but we also need to make sure they perform even on less than ideal situations, less than ideal conditions. So jump up to 2011, winter 2011 here. We had just finished remodeling our application framework for our website. And we noticed that our applications weren't quite scaling. They weren't quite performing like we wanted them to perform. And so we had built this framework around YUI 3. We really liked YUI. We used YUI 2 previously. We upgraded to YUI 3 for our new framework because it's got a lot of nice things. Componentization is the main one, and modularity is the main one. I'll get into that in a minute. But let's take a quick look at one of our pages. This is our retirement planner page. We use it for you input some of your personal information, how long you want to live, how old you're going to be when you retire. It says 67 here. I'll probably be 45 when I retire. Pretty sure I'll live to 190. And then the income, and you know, it'll help estimate how much you're going to have saved for when you retire. Well, looking at this page, when we built it out with our new framework, and this was taking in IE7, it was taking at least over 2 seconds to run not to load the page, but to initialize our JavaScript. Just our YUI code. It was taking over 2 seconds to run. So why was it so slow? Getting kind of angry here. Well, the easy thing is to say, hey, it's IE. IE, who can blame you if it doesn't perform well in IE? Well, it was also having trouble in Firefox. Firefox was taking about 1.5 seconds to load. So to get to the root problem, we're going to jump back to 2010. 2010 is really when we started building out our framework. We use a server-side technology, a JavaScript open source library called YUI. YUI is really great because it's got a lot of componentization built in. And what we wanted to do is build a framework that's flexible and reusable, and we built it upon this idea of components. Now this meshes right in with YUI3. YUI3, everything's a module, and you load modules. So it creates a really nice match between the Java side and the front end. So here's an example of one of those components, our tab view. We can skin it a couple different ways, reuse it in a couple different ways. The code that generates this tab view is obviously YUI builds that tab view from the configuration you pass in. But YUI is actually what builds this JavaScript. So in order to get YUI to build this JavaScript, we're going to write a little bit of Java. We're going to create a new tab view, add that tab view to the page, and then add tabs to that tab view. Now, you might be thinking, oh no, we're doing Java to write JavaScript. Is this a way of making YUI3 a Java-based framework? Not really, but it is important because we have our Java developers are predominantly outweigh the number of front-end developers we have at USAA. So we need to make sure that Java developers can write code that performs well and that uses all the best practices on the front end without them having to know too much about the front end. So the way for them to build a tab view on their page is they're going to put a single div on their page, put a YUI ID on it of tab view version 1. That's all they have to do in their HTML, just that one line of HTML. They don't have to worry about the right classes. They don't have to worry about the right structure and everything. They just add that. And then in Java, like I had showed you before, we're going to add our tab view using that YUI ID, and then we add the content in there. So back to 2011 and back to the performance issue that I mentioned earlier. This was the JavaScript that YUI was creating. What's really great about this is that it's all componentized, it's all sandboxed into its own anonymous function. You don't have to worry about namespace collisions. And that is really great because when you're trying to build a component-based library, you need to make sure things are separate. You need to separate your concerns, you need to separate your modules so that there's a lot less risk of them colliding with each other down the line. But what this does is each time we create a new tab view, we're going to run a new use statement. So we're separating everything out because we don't want to have them collide. But it does have the bad part of you're reusing a lot of code. So this is another page of ours. This is the valuable personal property page, and it's got basically a repeated pattern of you've got a category, you're going to put a number of items you have of your valuable personal property, and then an estimate of how much you think those things cost. If you notice, there's numbers that you put in for the number of items. There's a value, it's a monetary value. Well, we've got to format that. We've got to have a formatter out there that will handle the input and make sure that members don't put in letters for their numbers and that the currency has 2 decimal points in its value. Well, I had mentioned that each time we have a client input, or each time we have a component on a page, it's its own use statement. For our valuable personal property page, we've got about 28 of these client input formatters, and then its sister component is client input formatter service. We've got about 16 of those, so that's 44 use statements on the page. It looks like this. Not ideal, obviously. So here's just, all that configuration code. It's off the page. You don't even need to worry about it. Your performance problem is staring at you right in the face right there. We think it's that YUI statement and reusing the same code. So I just want to confirm with it, and so I tweeted Dave, and I said, hey, Dave, you ever run into any issues with this? He's like, hey, buddy, not a good idea. Don't go down that road. So we wanted to get rid of that multiple YUI instantiation, calling YUI. We didn't worry about use statements at this point in it. We wanted to focus on getting rid of the multiple YUI instantiations. So there's one way of fixing this, and that's to just lump it all in one use statement. It's not a great option because for two reasons. First is it gets rid of that asynchronicity. That's a nice word that I made up. Asynchronicity of loading components. So for my tab view to load, it now has to wait for client input formatter and client input formatter service and any other components that I want to load on the page. It has to wait for all those components to load. And then the same thing for client input formatter. It has to wait for tab view, not only for tab view to load, it has to wait for it to instantiate itself. And then the other part about it is if we've got multiple components on the same page, now we have to worry about naming and how we're naming our instantiations of that component. Not a really good solution. We didn't want to go down that path. I mentioned we need to be available. To be available, you have to reduce your risk. And so throwing code like this out there, it's going to introduce a lot of risk that things are going to collide. We didn't want to go down that path. Something else that someone had mentioned to me, a coworker of mine had mentioned to me, and it seemed really simple at the time, was, hey, why don't you take that YUI statement that you write at the beginning and just save it to a variable and then reuse that variable. Just create an instance of it and just reuse it. It seemed simple, but once I started plugging it in, it really started to make sense. It really started to come together. So instead of YUI paren instantiating it each time, I instantiate it once for the first component and then reuse it after that. And this is all done in Wicket. We built Wicket to manage this for us. And so I've got the multiple use statements, but here's what it did for our performance times. The blue bar is caching it using the instance. The red bar is instantiating it each time. You can see here a vast difference between the longer the bar, the better the performance it is. You see a vast difference. How much time calling YUI again and again takes. This is 10 times that we're calling it. And so this really helped us to overcome that initial performance trouble that we were having and really reduce those page load times in IE. But there's still some problems with it. I didn't mention this before, but because we have custom components that we're building, we've got to have a custom configuration to build those components out to pass in the path information to YUI. We don't just have that for our main config. Each component can have its own configuration. So I can have a main configuration, and then for my tab view, I'll have a separate configuration, and for client input formatter, I'll have a separate configuration. So to get around this, what we're going to do is pass in that main configuration to our YUI instance, and then each time we want to use a new component, we'll use the apply config method on our YUI instance. YUI returns an object that has the use statement. It also has apply config and a couple of other nice things to it. So for our first component, we're going to set one specific configuration, and then for our other component, we're going to set another configuration. This worked pretty well, but there's still some risk to it. And the risk is that when we set our first configuration, unless we override it in the next component, it's going to get passed down. So what we need to do is reset our configuration back to our initial main configuration. So to do that, we're just going to overwrite the config object on the YUI instance once with our default configuration. So on page load, we create our instance, we save our config, apply a new config, use the component, and then reset it. Apply a new config, use the component, and reset it. This really helped us improve our performance times, and it met all our criteria in order to get that, in order to get our pages up and running. Well, it is more code than before, and so applying configs and resetting configs, it seems like a lot of work. looking at the performance numbers, it's pretty much the same amount of performance time to apply those configs versus running no configs at all, which is what the blue bar is, running no configs, changing nothing. The red bar is changing them. So there really isn't much difference here. And so this was a good solution to get us moving down the road. Well, we're going to jump forward to the winter of 2012, or sorry, spring of 2012. Spring is important because in spring in Texas, it starts sometime late February is when spring starts in Texas. And contrary to popular belief, it does snow in Texas. Snow falls all the time in February in Texas. When it falls, it comes down in this liquid form, and that liquid, it coalesces in the mud and the dirt, and it creates these mud men. Anyway, that's a side point. Back to our client input formatter. So with client input formatter, we created this, when we were building out our library, we had this pattern of passing in a config object to our constructor, and then with that config object, we'd set our configs and build our code there. And so if you look back at our valuable personal property page, we still have a lot of inputs and a lot of client input formatters. And we were still running into the issue that we were using the use statement again and again and again, still having the same code being executed again and again and again. This was all in the generated source. This wasn't in our source code that we were writing. This was all getting outputted by Wicket. So we had to look in the generated source to see this. Anyway, to get to the point, while we had reduced the YUI instantiation down, and that had really improved our performance numbers, we weren't able to scale up like we wanted to because we still had these use statements being used again and again and again for a single component. So there's two ways that we fix this. To get to the first way, we're going to jump back to 2008. 2008 is important because I chose this date because it fit really well with my timeline. It actually isn't an actual date that this came out of, but I just needed a good date. Anyway, we're going to talk a little bit about jQuery. It's heresy to talk about jQuery at a YUI conference, but I feel it's a good example, and so I'm going to talk about it anyway. So in jQuery, when you add tabs to a page, they have this neat little pattern going on. And what this does is when the page is loaded, we're going to search through our page for any element with a class of tabs. And then from those elements, you can have one element with a class of tabs, you can have 10, it's going to instantiate the code. And what this means is that we can get rid of all those use statements, and we can have one single use statement for our client input formatter if we follow this pattern. So if you look at the HTML related to it, I decided to stop responding, which is perfect. Okay, we're going to run like this. If you look at the HTML built, it's just plain HTML. jQuery comes through, it selects the class of tabs, and it builds the tab view from that. So that means that you can have multiple tab views on a page with only one line of JavaScript, or 3 lines if you include the document ready. Back to 2012 and our component that we were building out. So instead of having client input formatters being built with our use statements, we're going to create a new module called Client Input Formatter Manager. And then we're going to take a config. That config is going to have a filter, and that's a CSS selector. And we're going to say, find all the elements on our page that match this selector. And then for each of these, create a formatter for that. And we'll get to that create formatter code. But what's so great about this is that we only have one client input formatter call on our page load. So we can have one component, we can have 50 client input formatter components, we can have 100 client input formatter components, but it's only one use statement on our page because the manager goes through the page, finds the elements, instantiates it from there. This almost solved all our problems, but didn't quite. This is the HTML for it. Real simple HTML, just the class. mentioned it almost solved all the problems. Well, if you remember back to the JavaScript I showed you before, client input formatter takes a configuration. What it's going to do is check for it's going to check for keys you shouldn't enter, so a blacklist, and then a format that we want our data, a field ID, whitelist, a whole bunch of stuff that's unique to that component, unique to that specific instance of that component. So with our, with our manager, how are we going to get that config data to our manager? Well, luckily, HTML5 has a new attribute called data-attributes. Some of y'all may be familiar with it. And what this is basically free-form to add custom attributes to your HTML. So now, not only can I add a class to my HTML, I'm going to add a data format that's going to have my format that I want my data in, and then a min length and max length is already in the HTML attribute spec, so we'll just reuse max length. And then with this, we can pass in the data to the client input formatter manager, that nice long name, and use it to build out our formatters. So here we take create formatter is going to take an element that gets passed in through the each method. It's going to save that element for later because we want to attach our events to that element. And then it's going to get the dataset attribute, which is our data dash tags. It's going to get the specific configurations for it. So you see format here. It's either going to find that format. If it's not there, it's going to fall back to a default. Same thing with min length. Same thing with max length. And then it's going to return a new client input formatter with that specific config. And so this is our way of getting that configuration information into our constructor. Now, there's still a performance problem with this, and it's that last line. It's the creating a new instance for each input format, for each input. And so how to fix this? Well, to fix this, we're going to jump back to 2009. 2009 is actually a real date that I wanted to pay attention to. It didn't just fit in perfectly, although it does here. Some of y'all may be familiar with Nicholas. He wrote a blog post on event delegation. And it's a really good blog post. If you're not familiar with event delegation, I recommend reading it. How many of y'all out here are familiar with event delegation? Good, a lot of you. I'm going to take a quick explanation of event delegation for those of you who aren't familiar. There we go. Okay, so we're going to talk about event delegation with the help of some teachers. I used to be a teacher. I didn't dress like that guy. He's actually the principal of that school, according to Flickr. That would have been a fun school to be at. I grew up in the wrong era. And you know, I think when I was teaching, if I wore that, I think the kids would have paid a lot more attention to me. Anyway, so we're going to talk about teachers in the classroom. So when I set up my classroom, they gave me desks, and I'd set these desks in a row format, kind of like you see here. And when it came time for me to collect homework, rather than me having to get up and walk to each desk and pick up the homework, or rather than having a bunch of kids crowd around my desk and mess with my stuff, I would have them pass the homework, and I'm sure you all did this. You pass the homework to the person in front of you, passed it to the person in front of you, passed it to the front row, and then I would come around, pick it up from the front row. Well, events have this same nature to them. When they get fired, so if we look at our example here, here's our DOM, we've got some inputs. You fire an event on an input. That event doesn't just occur on that input, it actually bubbles up through the DOM. So that event gets fired on the div, and it gets fired on the form element, and then it gets fired all the way up to the body element. And so what this means is instead of creating 18 different event handlers, event listeners, which is going to hog your memory, we can create one event listener on our teacher element. And we can say, hey, teacher, you're going to get all these events. Why don't you do the handling of it instead of having our kids handle all of it? So it's kind of a way to be lazy. Now, my students, they're perfect students. They never cause me any trouble. And I say that with no sarcasm at all. They They were ideal. They always wrote their name on their homework. I never had to go, hey, whose homework is this? Events are ideal as well. They're always going to have the original information, the original DOM element that triggered that event. They're going to have that attached. So what we can do is in our grade paper event handler, we can get that event information, or sorry, that student name, that element that triggered that event from the event. And then we're going to switch on it on that student information. We're going to say, okay, if it was Bob, if it's Bob's paper, he's a terrible student. He never does his homework, or he never does his homework. I'm just going to give him an F. I'm not going to bother with it. If it's Joe, he's my favorite student. No, he's always working hard. He's a top-notch student. I'm going to give him an A+. The rest of them, you know, it's late. I want to go home. I'm just going to give them all Bs. They'll be happy with that. So this is what our event handler on our delegated listener can do. It can take the specific element information and route it certain ways. So let's fast forward back to 2012, and we're going to look back at our use statement that creates that manager. Pretty much the same thing. The one thing we're going to do is pass in a root element that we want to add our delegate to. So this delegate, I have it on the body. You can put it on a form, or you can scope it any way to say any elements inside this form, any elements inside this div. For this example, we use the body. And then in our manager, in our actual manager function, instead of, when we write this manager, instead of creating a new instance for each input formatter, what we're going to do is write a single delegated event listener, and YUI already has this built in, so it's really great how it's got this built-in support for event delegation. We're going to say on blur of, on the blur event, we're going to call a callback function, and that callback function is going to take the event, it's going to get the element from that event, and then get the configurations from that element. Here I showed just max length. You know, in real life, you'd have all your configurations that you're setting there. It didn't fit on the screen, so I just show max length here. And then from those settings, you're going to pass that into your format input, and you're going to handle that. The important thing about this is that this is all on the fly. This isn't happening on page load. The one thing that is happening on page load is we're adding an event listener. And so with this change, this means that the same amount of code is used for one component, one instance of that component, that's used for 500 instances, that's used for 1,000 instances. So we can scale up our use of our components almost infinitely, the only limitation being how much HTML you can shove into your DOM. But you can just scale it up, and you don't have to worry about performance because it's the same amount of code being run, same amount of code being written out to the browser as far as JavaScript goes, and the same amount of code being run in the browser. All of it is handled on the fly through one manager. So go ahead and sum up the lessons learned that we had. Don't repeat yourself, even when you're generating code. You know, in our source code, that was one of the reasons why we made the switch, is this modularity, this reusability. We don't have to repeat ourselves when we're creating tab views. We don't have to write the same JavaScript instantiation. We let Wicket take care of that. Well, when it's automated, you kind of lose sight of what's being passed to the browser. So that brings me to my next point. Always view your generated source. Always make sure that what is being generated by your backend framework, whether it's Node.js or Wicket or whatever it is, that's what the browser cares about. The browser doesn't care about what you wrote. The browser cares about what's being generated. So take a look at that source and make sure that it's what you want it to be. Performance test with real-world scenarios. Don't test in a sandbox. Try mixing up your components. See how they work see how they work together. Add more than 4 components on a page. You know, figure out what a real-world scenario would be, and try that out when you're doing your testing, when you're building your framework. And that brings me to my next point. Scale your performance test. Don't just test it once. Don't just test one instance of it. Test 100 instances of it. Test 1,000. Test it until it breaks. Keep pushing the limits of your code so that you know where your limits are. Some photo credits here. The last thing I want to say is to anybody in the military here or anybody who's got a family member in the military, thank you, thank you, thank you, thank you, thank you for what you do. You make a sacrifice for us so that we can spend our days coding YUI happily from the comfort of our homes. Any questions?
Any questions for Kevin?
Hi. Just out of curiosity, of course you have to go through your process of choosing your tools and all that. We are leaning towards, I completely understand what you said about Java developers and all that. We come from the same background. We're leaning towards building the backend code to be on top of a JSP tag library. Mm-hmm. So rather than, I don't know, any thoughts on that? Did you consider that, and did you find some pros against that, or what made you use Wicked? We're gonna build a tag library on top of that's how we're gonna, and then of course we're gonna ask the backend developers to pass, of course, the data through JSON objects or tag attributes, that kind of thing.
Unfortunately, I spend my time in the front end. I really wasn't part of that Wicked process. As I mentioned, Java developers outweigh front-end developers at USAA. So, when decisions are made, they come to us for insight, but I don't know as much about Wicked and which way to go there as some of them would know. So, what I will say is that our previous application framework was using JSP tab libraries. It was kind of homegrown. Take a look into Wicked. It's got some really nice features to it that help with componentization. Unfortunately, that's as much information as I know. Sorry.
So on that note, front-end engineers pretty much will always be outnumbered by middle-tier devs. How does that mean you write, as a front-end dev, the JavaScript directly, or are you still using the Wicked stuff?
Wicked does come with built-in JavaScript libraries to it, but as part of my job is to write new JavaScript kind of adapters for Wicked. So the tab view, Wicked had a tab view built into it, but we really wanted to use YUI because of all the benefits that YUI has. So as a front-end developer at USAA, it's kind of my job to make sure that the code that Wicked is generating is that clean, performant code. And that's really one of the great advantages of using Wicked and using a framework like this is I can make the changes on my side, and the Java developers, they don't have to worry about it. They have other things to be concerned about.
Thank you.
Mm-hmm.
Hi, I was just curious if there were any other issues that you found using YUI on a large scale like this, other than what you covered.
Mm-hmm. I would say the one struggle that we're fighting right now is mobile, especially for use cases where we've got maybe one component on a page, and that component is like expand collapse. You can write, it just doesn't take full use of YUI. So, we've got Wicked and YUI integrated for loading our JavaScript on our pages, but what do we do when we don't want to load 30K or 40K worth of JavaScript just for a expand collapse component, or just for a stupid little JavaScript trick or something? So that's one of the things we're trying to figure out right now. And the presentation this morning was really helpful, when not to use YUI. That's a great example of when not to use YUI. Well, what do we do in that instance when loading of our JavaScript is so heavily tied into YUI 3? So that is one of the things we're trying to figure out right now.
Hi, yeah, you mentioned that you needed to support some pretty old browsers, and even going back to IE5. Does the code that you're talking about, did you have to write extra workarounds for the very old browsers, or did you just degrade and say, you know, no input, no client-side input validation for you guys?
So, see how to answer that. It depends on the case we're going with. So, and it depends on the amount of browser usage. We do recommend that for browsers like IE5, they use our mobile website because it's going to be less intensive. It falls back a little bit more gracefully. But we do have the ability in Wicket to kind of add in shims and stuff, kind of like you'd see in Modernizer. You'd see that in Modernizer. And so, yeah, we do have ways of saying, OK, you're an older browser, let's add this functionality in. One example is we use CSS3Py. And I will kind of caution CSS3Py, it works good initially, but you're going to have troubles with it as you try and scale it. It still has bugs in it. And while it's really great for some things, I'll just say there was a talk by Nicholas, what was it called? Graceful Degradation, I think, or Progressive Enhancement 2.0, and he talked about not falling back or not having that nice experience for older browsers. Those decisions, it just depends on what we decide at the time. It's kind of a case-by-case basis. Yeah.
Any more questions for Kevin? All right, great job. Thank you.
Thanks.